Hi guys, welcome to Unit 5, Day 5 right now. Okay, so we have been learning how to solve these systems of equations. We're going to learn the last one today, which it says in our learning target of pretty much using elimination. So let's do a little bit of review. First method was graphing. Second method was substitution. And today's method is called elimination. So we're going to jump right into an example, talk about all the steps of how do we solve with elimination. So just as it sounds, we're going to start eliminating, right? Canceling some variables out. So in step 0, it says that we need to do a lineup of the variables. That means that our x's have to be on top of our x's, our y's on top of our y's, and then our constants on the right side of the equals. Okay, so that is already done. Awesome. Now we need to determine in step 1 which variable to eliminate and make the coefficients opposite. So I go in and I check first which ones do I want to eliminate, the x's and the y's, and I want to do it the most efficient way. So I want to cancel out the x's. And why do I want to cancel out the x's? Is because one of them on the bottom equation doesn't even have a coefficient, right? That number in front of the variable. So it's going to be easy for me to multiply that total bottom equation by a number, which I'm going to multiply by a -5, okay? So in this step, we are going to determine to multiply everything in that bottom equation by a -5, okay? So now in the second part is that we're going to want to add these together and solve. So I'm going to have to write the first one on top. Actually, you know what? Let's multiply this out first. So we're going to get a -5x, -10y, and then I need some help on this. So -5 times 16, -80. Okay. Then I'm going to write the other equation. Now this is a preference. Some people like to keep it the same way, so maybe you want to write that first one on top still. So we have 5x minus 6y equals -32. Now let's draw this down. We are going to add these. So 5x plus -5x, they cancel out. -6 plus a -10, we're going to get now a -16y. And then we have a -32 plus a -80, -112, divide both sides by a -16, and we get y to be a +7. Be careful with your signs, right? Okay, but we know from the previous ways of solving is that it needs to be a point, right? A coordinate. So in step 3, it says to substitute the result into either of the original equations. Solve for the variable to find the ordered pair solution. So like in the previous ones, I like to set myself up so I know I have my y, I need to solve for my x. So looking at these two equations, for me, the bottom one looks a little bit easier, no negative, smaller numbers, okay? So x plus 2y equals 16. Now I'm going to pretty much substitute that 7 in for the y spot, and we're just going to solve here. So we're going to get x plus 14 is equal to 16. Let's subtract 14 on both sides to get a 2. And we got our solution, okay? Now it's super important, guys, to check the solution in both original equations. So what does that mean? The first equation was 5x minus 6y equals -32. If I plug it in, 5, the 2 goes in for the x, the 7 goes in for the y. So I get 5, so I get 10 here. 6 times 7, let's double check that. That's a 42, okay. And it looks like 10 minus 42, let's check that. Well, look at that. Negative 32 is equal to negative 32. That checks out. So then I'm going to check it into the other equation, which is x plus 2y equals 16. Plug in my 2 and my 7 into my equation. When I get 14, and look at that, 16 is equal to 16. So that means my answer is correct. Also, I could graph this in Desmos and notice that that is their point of intersection, okay? So make sure you check your work. All right, let's jump into some examples then. So in example 1, it says to solve the systems of linear equations by elimination. So same thing here. I'm going to first eliminate. Let's look here. We're looking for the x's and the y's. Which of them have the same number in front but opposite signs? That's the easiest ones to pick. Well, it looks like the y's, right? So I'm going to go eliminate my y variable. All right. This one's kind of nice because it already did a few steps. So it did the pre-step, right? They're already in that order. X is on top, Y is on top, constants on tops, and the numbers in front are the same opposite sign. So we're like going in to a few steps in already. So we're going to add these. So 2x plus 6x is 8x. Positive 5y plus a negative 5y cancels, equals 17 plus a negative 9. All right, that's an 8. Divide both sides by 8. X is equal to 1. Fantastic. I have half my answer. I'm going to start up with my coordinate already. And now I get to pick either of the equations, whichever one looks easier to me. I'm going to pick the top one because that one doesn't have any negatives. So I'm going to go 2x plus 5y equals 17. Plug in a 1 for the x spot. We're substituting in there. And we're going to solve for y. So 2 plus 5y equals 17. Let's subtract 2 on both sides. 5y is equal to 15. Divide both sides by 5. And we get y is equal to 3. And I'm going to plug that into my coordinate right away. Make sure we go to Desmos, we check. Yeah, that is where they have their intersection. Okay. Then let's try out this guy right here. Part B. I'm going to first eliminate, ooh, I don't like this. That bottom equation doesn't have the x's and the y's on the left side, kind of like in standard form, right? So let's rearrange that. So technically I have to like subtract the 7x. And the top one's good. So the top one, 7x plus 2y equals 10. And then when I did some inverse operation, the bottom one becomes negative 7x plus y equals negative 16. All right, so that's like my new system, guys, right? And now we're going to figure out which one we want to eliminate. So look at your x's and your y's. It looks like the x's, right, have the same number, opposite sign. So we are going to go with the x's. We're going to add them right down. And when we do that, they cancel. And we get now a 2y plus a y, 3y. Then we get 10 plus a negative 16. I'm going to double check. Okay, that's a negative 6. Divide both sides by 3. And y is equal to negative 2. I'm going to set myself up for success here. So I'm going to start my final answer as a coordinate. It's a y value, so we know that goes in the second slot. And now you have that option. Going back to those original problems, which of them is going to be easier for you? Totally, it's a preference. I'm going to try, you know what? Yeah, I'm going to try that second one. So second one, y equals 7x minus 16. I'm going to substitute a negative 2 for the y. So negative 2. 7x minus 16, and let's just solve for that x. So we're going to add that 16 on both sides. I'm not quite sure with that answer, so -2 plus 16. Oh, positive 14, okay. I like to be double sure, you know, with those negatives. And then I want to divide both sides by 7. X is equal to, double checking, 14 divided by 7. It is 2. Awesome. So I'm going to plug that into my coordinate. And then, of course, I can check that in decimals to see, did those two lines actually cross at 2, -2? And then that kind of makes me sure that I did it correct. Okay, guys? All right, awesome. This is the end of part 1. Make sure you go to part 2.